Hello everyone, my name is Mansa, pursuing BTech second year in Vasred Venkatadri Institute of Technology. Today I am going to discuss about first come first serve scheduling algorithm. Let me share a screen. Yeah, first come first serve scheduling algorithm. First of all, we will see what is meant by first come first serve scheduling algorithm. In this, what we do is to allow the process to execute in a linear manner. This means that whichever process enters the ready queue first, that is executed. This shows that this algorithm follows first in, first out FIFO principle. That is, whatever is added first, it will delete first. This scheduling algorithm is non-preemptive in nature. That is, if a process is already running, then it is not interrupted by another process until the currently running process is executed completely. Here we will see one example regarding this algorithm. They have given process IDs, process names, arrival time, burst time. Process IDs from P1, P2, and so on, P6. Process names A, B, C, D, E, F, and arrival times, burst times. Arrival times are 0, 1, 1, 1, 2, 3. Burst times are 9, 3, 2, 4, 3, 2. We will apply first come, first serve scheduling algorithm for this table now. In order to apply this FCFS, that is first come, first serve scheduling algorithm, first, we have to calculate the completion times for each process. To calculate the completion time, we will use Gantt charts. How to draw Gantt chart? In the given table, the minimum arrival time is 0. That is for process P1. Process name is A and having process ID P1. So we will consider process IDs here. So P1 process arrive first and its burst time is given as 9. So it completes its execution when it reaches 9. See here, P1 is from 0 to 9. At the time P1 completes its execution, if we consider all other process, their arrival times are less than 9. So all will reach at the time. In those arrival times, next minimum arrival time is 1. Here we have 1 for 3 process, but we will consider the first one, that is P2. P2 burst time is given as 3. So it's completes its execution when it reaches 12, that is 9 plus 3. That is burst time of P1 plus burst time of P2. So for P2 it is 9 to 12. 9 plus 3 equal to 12. Again for P3 burst time is 2. So it completes its execution when it reaches 12 plus 2 is equals to 14. Next one, P4. P4 burst time is given as 4. So it gets completed its execution when it reaches 18. 14 plus 4 is equals to 18. Next, P5. P5 burst time is given as 3. So it gets completed its execution when it reaches 18 plus 3 is equals to 21. When it reaches 21, it gets completed its execution. Next, last process P6. P6 burst time is given as 2. So it gets completed its execution when it reaches 23. That is 21 plus 2 is equals to 23. Now we will write completion times for each process from right side to left side by traversing from right side to left side. For P6, it is 23, P5 21, P4 18, P3 14, P2 12, and for P1 it is 9. After writing, see here I have written the completion times. After writing completion times, we have to calculate the turnaround time. Turnaround time is the amount of time taken to fulfill the request by the process calculated by taking the difference between the completion time and the arrival time. So just now we have calculated the completion times, right? By taking the difference of completion time and arrival time, we will get the turnaround time. So see here, for process P1, completion time is 9 and the arrival time is 0. 9 minus 0 is equals to 9. And for P2, 12 minus 1 is equals to 11. For P3 completion time is 14 and arrival time is 1. So the turnaround time for process P3 is 14 minus 1 is equals to 13. And for P4, 18 minus 1 is equal to 17. For P5, 21 minus 2 is equals to 19. And for P6, 23 minus 3 is equals to 20. Like this, we will calculate the turnaround times here. After this, we have to calculate the waiting time. What is meant by waiting time? Waiting time is the time spent by the process in the queue waiting to get executed. Difference between turnaround time and the burst time. Means, if we calculate the difference between turnaround time and the burst time, we will get the waiting time. See here, for process P1, turnaround time is 9 and the burst time is 9. So the waiting time for the process P1 is 9 minus 9 is equals to 0. For process P2, turnaround time is 11 and the burst time is 3. So the waiting time is 11 minus 3 is equals to 8. For P3, 13 minus 2 is equals to 11. For P4, 17 minus 4 is equal to 13. P5, 19 minus 3 is equal to 16. For P6, 20 minus 2, that is 18. So like this, we will calculate the waiting time for each process. After this, we have to calculate the average waiting time. The sum of all waiting times divided by the number of processes gives the average waiting time. So we will sum up these all. 8 plus 11 plus 13 plus 16 plus 18 whole divided by how many processes we have taken? 6 we have taken. So the total divided by 6 we will do. Here the total is 11 plus 8, 19, 19, 29, 32, 42, 48, 58, 66. The total is 66 right here. So 66 divided by 6 we will do. We will get answer 11. So the average waiting time for the given table is 11. Like this, we will apply first come first serve scheduling algorithm for any type of process. Where we use these scheduling algorithms. Buying a movie ticket from the ticket counter is a perfect real life example of this algorithm. The person who comes first and stands in the queue gets to buy the ticket first. Similarly, in the first come first serve scheduling algorithm, the process which arrives first, that is executed first. Another example is billing counters in a supermarket. It is the real life example of first come first serve algorithm. The first person to come to billing counter will be served first, later the next person, and so on. The second customer will only be served if the first person's complete billing is done. Similarly, in this scheduling algorithm also, the process which arrives first will be completely served, and later the next process waiting will be served. What are the characteristics of this algorithm? The characteristics of first come first serve CPU process scheduling are: implementation is simple, it does not cause any casualties while using, it adopts a non-preemptive and as well as preemptive strategy, it runs each procedure in the order that they are received. Arrival time is used as a selection criteria for procedures. Next, advantages of first come first serve scheduling algorithm. The advantages of first come first serve CPU process scheduling are: In order to allocate process, it uses the first in first out queue. FIFO principle it uses. The first come first serve CPU scheduling process is straightforward and easy to implement. In this situation, preemptive scheduling, there is no chance of process starvating. As there is no consideration of process priority, it is an equitable algorithm. Next, this algorithm also has disadvantages. So the disadvantages of first come first serve CPU process scheduling are this algorithm has long waiting time. This algorithm favors CPU over input or output operations. In this algorithm, there is a chance of occurrence of convoy effect because it is so straightforward. It is always very not effective. Extended waiting periods go hand in hand with this, and all other orders are left ideal if the CPU is busy processing one time consuming order. Conclusion. First come first serve stands for first come first serve. It uses the FIFO principle. It is the simplest process scheduling algorithm. In this, the process which arrives first, it will be served first. Billing counters in the supermarket are real life examples of this algorithm. Because of the simple nature of this algorithm, small process suffers starvation when a big process arrives first. This we will call as convoy effect. So we will say the main disadvantage of this scheduling algorithm is convoy effect. That's it. Thank you. Thank you for giving me this wonderful opportunity.